Hi everyone, I'm Skywaston and this is fourth part of the Godot FPS tutorial series. And in this video we are going to finally make the enemy. So let's do this. So similar to the player, I will create a new scene for the enemy where we are going to make use of character body 3D. Let's save it inside of a new folder in our main directory, and let's have it as enemy.tscn. Now just like we did with our weapon, we had this display placeholder, and within this we had our placeholder meshes and animation. So I'm going to do the same here for the enemy, as later on we will add the final model in later part of this series. Okay, so similar to our weapon, I'm going to name this node as display placeholder, and inside of this let's create another node. It's going to be the root, and we are having a root because we will make a very basic animation for enemy shortly. So this is our mesh, and let's use a box mesh and have a height of 2, and let's put the enemy above so the pivot is around the bottom. Okay, and to the body mesh I will add a material and set it to something red. Okay, so I will also add another 3D mesh, and this is going to be to show the eyes, because we cannot see the player, so we didn't do anything like that, but we can view the enemy, and in order to realize perceive where the enemy is looking at, we need to have some kind of display. So for that I will use a mesh that will represent the eyes of the enemy. So this is our eyes, and I will put it in the negative z direction, as that's going to be our forward direction. Think this looks good enough, and I will add a material to this, and let's color this to something black. Okay, so with this done, now let's add a collision shape, and yeah, we need to make sure that the collision shape is a direct child of the enemy. So it's not going to be a child of display placeholder, and I'm going to use capsule mesh capsule shape for the collision, and we don't have to do any changes to this. The default size is fine. So with this done, this is our enemies display done, and now I will, similar to player weapon, I will create enemy weapon. Okay, so yeah, so we can actually duplicate the player weapons scene and have the new scene as enemy weapon, and I will move it inside of our enemy folder, and let's do the renaming, and also let's make sure to remove the script, and we will not be needing a muzzle flash, so our enemy is going to be doing melee attacks, so it's not going to be a ranged weapon. Okay, so yeah, I can for now remove the animation player, and in our display placeholder, let's make it similar to a hammer. Okay, so let's rename this upper to tail and this lower to head, and I will reset the rotation and turn it 90 degrees, and let's put it like this. So this is going to be the enemy's weapon, and perhaps let's also have a animation, a couple of animations. So let's look at player, and we are going to have animations in a similar fashion, except that we will not have shoot, empty and reload animations. So there's only going to be idle and attack, as this is a melee weapon. Okay, so let's create an idle animation, and this is going to be the default, and let's set the nearest FPS to 0.1, and let's enable snapping. This will make creating animation easier. So let's first of all keyframe the position and the rotation. Okay, so this is done. This is our idle animation, and then I will create a new one, and this is going to be our attack animation. So here again I keyframe these two properties, and let's create something very basic. I will rotate it around X axis, and maybe let's rotate it a little bit more, and let's keyframe the rotation, and then on 0.2 seconds I will rotate it further, and let's keyframe this as well. And now after doing this, let's bring it back to rest. I will do a little bit of I don't know what the term is, but um, let's have the momentum, a little bit of momentum. Okay, let's display that. I can't recall what the term is, but I hope you get the idea. So yeah, I think this is it. It's a 0.4 second animation, and I will highlight all of these and set easing to ease in and out. So this is going to be our enemy's weapon animation, attack animation, and this is pretty much it. Okay, so with this done, I think we can finish up the enemy weapon script. Okay, so after this is done, we don't have to come back to it again, even though we will come back after some time, but that will be just for some very minor additions. So I will name this as enemy weapon, and let's create a group, and this is going to be for the stats, and let's have the first variable as weapon range, and let's have a range of 1, and then another group, I will call this references, and let's have a reference to the animation player, and another reference which is going to be our attack origin. So I will let you know what it is shortly. So it's going to be a node 3D, and now I will define the method which will be called through animation player. Okay, so it's going to be our okay. So first we need to define an attack method similar to the player weapons script which we have over here. Though this had quite a bit of things, but we will just be over here playing the weapons animation, which is in this case attack. And similarly I will have a function which will be called through the animation player in our enemy weapon, and this is going to be our attack, what should we call it, attack hammer or something like that. So in our case we will not have any ammo or UI. We will be adding SFX. There will not be any muzzle effect. So yeah, this is our space state, and inside of here our starting point is going to be the attack origin. So let's have that over here, and our 2 is the final destination, and it's going to be from and minus. And as we know, as I said in the earlier video, the forward direction is in negative z direction. That's why we are subtracting, and it's going to be attack origin global transform basis z times our weapon range, or maybe I should rename this to attack range. So this is our final point, and then we can create the query and process it, and we will get the result. And for now we can do something like so we can have something like if result dot what's the name of that property, collider. Okay, yeah. So if result dot collider is player, we can just say something like attack player. So we will update this part later on. Okay, so yeah, this is it, and I can remove the else statement. So this is it for the our enemy weapon. Okay, I will also remove that line, the collision position one. So yeah, this is it. So our weapon is at least for now ready, and I can close it and move on to the enemy. And in enemy as well, I will do one more thing, a little bit of setup that is remaining, and that is I will have 2 basic animations, and these are going to be very simple. So the first one is idle, and for the idle one I will select the root, and I will just keyframe the scale, and then I will duplicate it to the very final frame, and in the middle I will going to scale it down a little bit. Let's say 0.9. Let's see how it looks like first. Maybe let's go with 0.95, and also let's enable looping. So this is going to be the looping animation. Okay, so let's maybe extend it and make the animation 2 seconds long. So yeah, this looks good to me. This will do it for us for now. So this is our idle animation, and finally we are going to have death animation for this enemy, and this is going to be again based around our scale, and this is going to be very quick one. Over here I will going to yeah, I will increase the height to by 1.05 units, and then I will going to make it almost close to 0. I will not set it to exact 0, otherwise we get an error warning. So I'm using this very small value over here. Okay, and this should do it. Oops, okay, I didn't saved it. Yeah, so this is the keyframe added. So again I can set its easing to ease in and out, and let me just check if okay. So in idle as well I hadn't set the easing, so I think yeah. So yeah, this is our death animation for the enemy. Great. So our animations for the enemy is also complete, and let's add the weapon. Okay, so this is the weapon we created, which is enemy weapon, and I will place it towards the right. Yeah, this looks okay to me. And one more thing, you will realize that the weapon is it should be behind the enemy mesh, and in this case we can fix that. So we earlier did it with player's weapon, and since this is first person view, we don't care about this weapon being clipped by player's mesh because we can't see it. What we really did care about was how weapon was clipping up with walls and all such places. So here it's okay, but for our enemy weapon we can go easy. Okay, so yeah, so one more thing, I believe. Okay, so yeah, this is unique to this scene only. So all I have to do is disable Z scale, and that should fix it. Yeah, this is it. This is done. Let's also see how the animation is going to look like when the player is attacking. Yeah, looks good. And we will later on add the final model in the later part of the series. Let me make it uneditable again. So with this done, I will just fill in the reference for attack origin. I realize I didn't fill the reference for animation player, so let's do that. And also let's do one more thing, which is within our attack I didn't called that method which we have to call to initiate the actual attack through code. Let's do that here. It's going to be attack hammer. Okay, so this part is done. Okay, nice. So with this done, I think we are all good to go, and we will see if there is anything we are missing out. But for now, let's proceed ahead with adding the enemy to the world. So I will put all enemies inside this 3D node. First of all, what we are going to do is add the enemy inside of our world. So this is it, and Okay, so the enemy is not exactly on the ground, and I realized the player till this point was also uh, quite underneath the ground. Let's put it up as well, and let's adjust enemy rotation and put it somewhere over here, and let's run the game. And this is our enemy. I think maybe we can make it a little bigger, uh, but for now let's go with this only. So this is our enemy, and actually I will do a little bit of rearrangement of this level so we can better see how pathfinding is going to work. Okay, so let me just quickly do that. Okay, so I think this is for now fine. This is our enemy, and yeah, so let's start with adding navigation. So our enemy units can um, make use of pathfinding algorithms provided by Godot. So they can navigate through this world, through this maze, and also, most importantly, uh, do so smoothly when there are a lot of more enemies. So we need to enable obstacle avoidance as well. So all of this thing is quite easy as Godot provides us with the nodes, even though I believe they are still in experimental state, but it works. For me at least it has worked till now very good. Anyways, so yeah, I will go with navigation region 3D. This is the node we will be making use of, and let's call this nav region, and this is going to be the new parent of our world node, which is a CSG combiner. So with this done, I will select nav region and we'll see a option over here which says bake navigation mesh. So and yeah, we need to also make sure that we have a navigation mesh created. So let's do that. And now if I select bake navigation mesh, we get the mesh, and you can see that it has already generated for us the paths, and these highlighted regions are the places where our enemy is going to traverse, and these areas which are not highlighted is the restricted area where the enemy unit will not move. And of course, to make movement we will now have to make use of navigation meshes methods which will help us in setting up velocity and direction and all that stuff. Okay, so let's look at a couple of things. You can ignore this part. By default this is there's always a little bit of offset from the ground. I don't know the specifics, so I will not say much about that. But we are going to look at the settings of the nav mesh, and I am mainly concerned with the agents tab. And our agents, as you know, they are 2 meters tall. So if I go to enemies, which is over here, and if you remember, I made the enemy mesh 2 meters tall. Okay, so let's use that same value over here. So in our nav region we will have the height to 2, and the radius is simply the agent's radius. So let's see what was the value for it. It is 1. So I believe one is yeah, so one is the overall. Okay, so it's basically point 0.5. um, point 0.5 is going to be the radius, and it's already correct, but I will still leave out some space. So let's go with 1. So that is basically an extra zero point 0.5 meters of space around the enemy, and we can keep the remaining things as it is. And let's bake the mesh again. So yeah, you can see there's the restricted area has increased a little bit because we have increased the radius of our enemy, uh, of our agent to be precise. So with this done, I believe we are all good to go. Let's go to the enemy scene and create enemy script. I will name this enemy. So first of all, I will first define a state script for our enemy. So let's create a folder inside of enemy, and let's name this states. Inside of this, the script will be base enemy state, and let's name this class. So similar to the player's component script, actually we didn't make one, but for enemy we will make, because we are going to be a little bit more explicit here. So this script will be responsible for state management, and usually what we are going with is a finite state machine for our enemy, and stuff like this is much simpler and manageable with enemy compared to player, where things are rather way more interconnected, and I don't think we needed that level of complexity for player, but for enemy I think it's worth it. So let's do that, and it's going to make our life a lot easier, right? So yeah, let's do. And it's going to be similar to the player components structure that we had, but there will be a couple of differences, mainly that there will be less amount of functions to override. So this is going to be for physics process. I will copy this and paste another, and this is for process. And finally we are going to have a method which is end, and I will show you how this is going to work in just a moment. So now let's create a script, another script, and let's call this chase state, and this is going to extend our class that we just made. So this class is basically acting as an abstract class, so we will not really have any definition over here. It just defines the structure, the template that the child classes are going to have. Okay, so in our J state, first let's define the class name, and then I will going to override physics update, the function that we defined in over here. First let's get reference to the player. So we will first do the movement part, and of course before we do that we need to do a couple of things. So first of all, we will need to have so let me just close player. So since we are now using navigation region inside of enemy, I will have another node which is going to be navigation navigation agent, yeah, right over here. And what it's going to do is allow us to enable avoidance. So let's switch it on. So basically what it will do is that it will allow us to uh, while enemies are moving towards their target, if there are multiple enemies, and they will of course collide with each other, and we don't want that kind of behavior. We want it to go smoothly, so uh, they don't get all messed up. So that's why we will enable avoidance. And I will set the height of agent to 2 and radius to 1, similar to what we did over here. And now with this done, I will add a reference to the navigation agent. So let's define a group, and inside of this have a reference to our nav agent. So with this done, I will go back to our chase state, and I will going to, and again one more thing, in our base enemy state I will have a export variable, and this is going to be our enemy. So yeah, this is defined. So now in movement we can do enemy dot nav agent dot target position equals to player dot global position. So this will set the target position for our nav agent. So the way it's going to work is that, suppose if this is our enemy, and once we set the target position, it's going to have a bunch of points that go towards this target. And right now I believe this will be only consist of 2 points, but let's say if our enemy was like somewhere here, so it would have most probably going to have gone with some kind of this movement, and we will have these set of points over here along the path. So we need to know these points, okay? And for that, what we do is define a variable which is next path position, and this is going to be vector 3, and then we do enemy dot nav agent get next path position. Let me make the screen full. Then let's find the direction towards that point, and this is going to be our enemy dot global position dot direction to next path pose. With this done, we will next have a variable which is our target velocity, and this is going to be our direction times speed. And I think let's define this speed in our enemy class. So we can have something like export var speed. Let's have it as 10 for now. Then in our chase state we will use this variable enemy dot speed. With this done, all we have to do now is set enemy's nav agent's velocity equals to so we will not directly set a target velocity, because we want the y component to remain whatever it is. So we will only modify x and z components. So we can say target velocity dot x and target velocity dot z, and for the y it's going to be the whatever the y velocity is, right? and we are not going to interfere with that, because that will be the gravity of the enemy, and that is independent of our enemy's movement. And finally we are going to do rotation, which is going to involve enemy looking towards the player. So this is going to be a target look position, which is the place we want to look at. And over here, instead of velocity, we will go with our next path position, because we are concerned with the point, not the velocity. So this is going to be X and Z, and for the Y it's simply going to be enemy's Y position. Okay, so suppose if the player is jumping, we don't want that Y component to come up, right? And I don't think it will come up anyways, but I guess we can just go with directly next path position. Next we are going to calculate the target basis, and this is something which I don't know myself very well how it works. So I'm just going to write it off. I think Gemini helped me in that when I first worked on this part. So it's going to be target look position minus enemy dot global position. Then with this done, we will set our enemy's basis to be equals to enemy basis, which is the current value of it, the current rotation, and we lerp it, which is basically we interpolate to the target value, which is going to be the target basis, and let's have a weight of 0.1. So this 0.1 is going to define the smoothing. So we want the enemy to rotate towards the player, but like not just snap to the location where player is. Okay, we want it to turn smoothly towards the player. So this is what slurp is going to do. It's going to rotate from the current enemy's basis to the target one. And when I say basis, I believe contains yeah, of course it contains the direction data, but it's I think mainly concerned with rotation and scale. So yeah, so this part is done. So now I will go back to enemy, and let's define a few more things and enable our enemy movement. Okay, so I will also have gravity similar to player, and let me just see what was the gravity's value. It was 100 and the speed was actually 10. So let's have a speed for enemy that is lower than this, and I realized that maybe it's a good idea to just use the gravity defined in project settings, I guess. But anyways, let's have the enemy's speed to be 5, and also I will have another group, and this is going to be for the states. So first let's define a variable which is going to be our states container. And then the variable which is our chase state itself. Then inside of our ready, so let's first define the process through which we will be setting velocity. Okay, so it's going to be velocity dot computed, and I will shortly tell you what it does. Let me just write the essential code for it first. So on nav agent velocity computed, so this signal, when it is emitted, it returns, I'm sorry, it has this argument that we get, and we are going to use this. Basically what it is, the safe velocity is the updated velocity which does all the calculations for avoidance. So like in our chase we set the velocity over here, so that's great, but this is not going to be the final velocity. This nav agent is going to do some computation on this velocity, so we will get a new velocity which will have direction, and which is going to be so that enemy doesn't make collision with other enemies, right? So here what I will do is just update velocity, which is now the character body 3D's velocity. Okay, I will update this velocity to safe velocity. Okay, and finally call move and slide. So we are going to call move and slide over here, not in physics process, because we want to get hold of the safe velocity, right? So our enemy moves smoothly, as we are using nav agents now, navigation mesh. So yeah, this is it, and let's also define physics process, where we are going to do our usual gravity and all that stuff. So let's start with gravity, and this is going to be, if we are not on floor, then our velocity dot y is going to be subtracted by gravity times delta, and over here we can comfortably manipulate the y component, because we are not messing up with it in our movement code, right? So it's completely fine. And if we are on the ground, we will have velocity dot y equals to 0, and then we are going to call our chase states physics update and pass in the delta. So yeah, this is done. Just one more thing, and that is I will have this function which is setup states, where all I have to do is that if you go to the base enemy state, we have the reference to the enemy. Let's define let's remove export, and we are just going to directly set reference to the enemy from over here itself. So the chase states enemy reference is going to be is equals to self. Now of course we will do a couple of more things, but for now let's just stick to this, and call this setup states function in ready. So yeah, that is pretty much it. So let's add references wherever they are required. So first of all, I will create a node, and this is going to be the base node, and let's call this states, and inside of this have another node, and let's call this chase state. Okay, and I will drag and drop chase state over here, and in enemy I will select our states container. I don't think we need to make it node 3D, we can just have it as our base node. So yeah, this is it, and this is our chase state, and this is our nav agent. So yeah, this is it, and now let's run the game. And okay, so maybe so the movement is working good, but the rotation is kind of not correct, and maybe it's a good idea to just you remember that I I just directly overall set the path position like this, and maybe it's happening because of this small offset that we have. Anyways, let's fix this quickly, and all we have to do is not modify the y component. Okay, keep it as it is. So this is the z, and for the y we will have simply enemy's global position dot y, and that should do the trick. Yeah, so this is working correct now, and we can see that the enemy is able to navigate through this whole area. Let me just put the enemy somewhere like over here, right? And let's see how it gets toward the player. So yeah, the enemy movement is working. So the enemy is now following us, looking at us. So this part is done. So now we can make the enemy have more behavior, so it just doesn't start chasing us. Before moving ahead, let me just also show you. And okay, so this is error we often get. For now we can ignore this. Okay, so this is error related to, I'm not entirely sure, but at times our target vector becomes 0, especially when enemy is way too close to our player, and then this kind of thing happens. We will fix this stuff shortly. For now we can ignore this, and also let's have some space over here. Yeah, so yeah, I was saying that let me also see how the enemy obstacle avoidance work. Okay, so I will have a bunch of enemies in the map, and let's see how do they move towards the player. So yeah, that's great. And so they are not getting messed up between among themselves. I'm sorry, I'm not getting the right word when speaking English, so my apologies. uh, yeah, so this is done. So yeah, the obstacle avoidance is working great. I will remove the additional enemies, and now let's proceed ahead with adding additional behavior to the enemy. And I will also going to remove these let's have them. Okay, let's have them. We will go with this layout only for now. Let's have the enemy somewhere over here. So first of all, we don't want the enemy to straight away start chasing player, right? So we are going to have a couple of states. So the idea is going to be that once the player has entered a certain area, it's only then enemy is going to start attacking the player, right? And of course there are a bunch of states the enemy is going to have. Let's define them and you will get the idea. So I will define an enum for enemy states. The first one is going to be the idle, the second one is chase, then we have the attack, and finally the death state. Let's also have a look state because we will be needing it. So we are going to have these 5 states. Okay, so let's define let's create those scripts first. So let's quickly make an script for idle state. I will name this idle state, and let's prepend it with enemy idle state. I think this is much better. And also this is going to extend base enemy state. And I think just to be consistent, let me just rename the class to enemy chase state. And let's update it over here as well. So this is our idle state, and I will just quickly have a start method in which I will be playing the idle animation. Let me add a reference to that. Export where animation player, and then enemy.animPlayer dot play idle. That is it. And one thing I'm going to do with this placeholder animations is that I will be using idle animation for running as well. And yeah, that's going to just be for now. So I will define a constant which is animation duration. I think I should say animation transition duration, something like this. So when we transition from one animation to another, we want there to be a blend. We don't want to just quickly snap to a different animation, right? So for that we are going to use this transition duration. And for now let's go with something like 0.5, or maybe let's make it a little faster, 0.1. Then I will go to the idle state and have the transition amount over here, and that is it. And let's also play this at the speed of the default speed, which is 1. Okay, so this is our idle animation. Now I will duplicate this same script and make look state, and let's rename this to enemy look state. And this is also going to be same. And then we are going to have attack state, and I will add the main logic later on. For now let's just define them. Okay, let's set these scripts up, and again let's have it as it is. And finally we will have the death state. And this is it. For death animation we will just replace idle with death. Okay, and maybe we can remove this. We can, okay, maybe later on when we add the model, let's have this, let's keep it over here. Okay, so this part is done. Let's go back. So let's go back to the enemy script, and over here I will add references to the other states. Okay, I'm sorry I didn't update the class name. So this part is done. Yeah. So yeah, after having done this, I'm going to define a bunch of variables. So first one is going to be old state, which is old state enemy state. I think let me just rename this to state only. After all, this is inside of enemy class, so let's make it simple. And then we will going to have state. This is going to be our current state, the active state, and we are going to start off with the idle state. So again I will define a setter, and if the new value is same as the current value, we don't do anything, we just return, and then we update our state with the new value. But before updating state, we set our old state to be equals to our existing value, which is now going to be the old state value, and after that only we update our state to the new value. Okay, there's just one exception to this rule, and that is if our old state is equals to the death state, then we don't update our current state. Okay, and we just simply return out. So here I can just comment out update value. So before proceeding ahead, I will make a helper method, and this is going to be get state node. So this is going to return us the node, which is base enemy state. So any node, any class that derives from it, which is basically all of our states, and this is going to get us this node provided we have argument as the enum, which is our state enum. So the way it's going to work is that if our state equals to state dot idle, then we are going to return the idle state. Similarly, I will just copy this, and else if our state is look, we are going to return look state, and so on. And finally we return null if it's none of the above. So after having done this, I will go back above here, and what we have to do is, since now a new state is set, I will like to call end function of the old state, right? So I will say finish old state, something like this. So let's get the old state node, which is going to be base enemy state, and I will use this function over here and pass in the old state variable, and finally I will call old state nodes end method. So whenever we switch from one state to another, the old state's end function is going to be called, and after which we are going to call new state's start function, which is going to be call new state, or maybe let's say something like start new state. I don't think we need an underscore. I think this is much better, and let's say just say state node, and this is going to be get enemy state node, and then finally state node dot start. So yeah, this is it, and actually we will need this state node to be global. So let's define this here. We don't need this for old state, but we do need this for our state node. So we can remove this var declaration over here, and this is it. Just make sure you do this, okay? And yeah, I think this is it. So now I will go back to setup states, and over here I was earlier setting enemy of only chase state. Now we can set enemy value of all the states, so we can quickly get it. Dot get children. Let's just have a type. Let's add a type just so that it's easier to see methods and all. Let's say s node base enemy state equals to s, and then I will set its enemy to be equals to self. This part is done, and now I want to set the starting state of our enemy to be equals to state dot look. So this is going to be the starting state, right? And over here I am having the default value to be idle. Okay, but the reason I'm switching over to look is that really idle is just for we will mainly be going to look only and use it as idle, and we want that our old state variable is at least updated once. So yeah, so with this done, let's update over here this. So this is simply going to be our state node dot physics update. So whatever is the active state, right, its physics update is going to be called. So now we have to do is that I will add a detection area reference, and we are going to add this detection area not inside the enemy scene but inside of our main scene. And let me just give you an overview of what we are going to do. So suppose for this enemy I will have, say, an area 3D which is detection area over here, and once the player enters this, the enemy is going to transition from its default the starting look state to the chase state, and this is going to happen only once. So what it means is that once we are into the chase state, the enemy is always going to look for player and attack it. We won't be going back to our default position. So I'm making this very simple right now, and of course you can add your own logic on top of it, but for the purpose of this tutorial I will keep things simple. So with this understood, let's proceed ahead. For detection area we are going to connect body entered signal to a method which is on detection area body entered, and this is going to be inside here. So if our body is player, so first thing we will do is change our state to chase. Okay, so from look to chase, and the reason I say from look is, as I said before, this is only going to happen once, and it's only going to happen when the player enters detection area for the very first time, because after the player has entered, I will simply disable this detection area. So what I will do is detection area dot collision layer to 0 and detection area dot collision mask to 0. So here I'm basically disabling the collision, and this is just to make a very simple enemy AI, and you can of course add your own logic on top of it. So maybe you want that enemy returns back to its position after player gets far away from the enemy, or you may want to also add patrol logic, enemy patrol logic, something like that. So you can for that maybe add another state and all. Yeah, but for this video we will keep things simple. So once the enemy starts chasing player, that is it. It's not going to return back to the look state. Okay, so this is it. We disable the collision, and let's see this in action. Okay, um, so in 3D I have this enemy, and inside of this I will add a area 3D node. I will not do this over here because I want this area 3D to be unique for all different instances of enemy, so that's why. And let me just go back over here, and yeah, I haven't set all the fields yet, and also I haven't added all the other states, so let's quickly do that. So yeah, this is done, and inside of our main scene I will complete this detection area. So let's add a collision shape, and let's make it a simple box shape 3D, and let me just put this area somewhere over here, and I'm going to make it a little bit closer to the enemy so that we can actually see the change in state. Let's make this large and also tall in case our player jumps, so we don't miss this area in any way, right? Yeah, I think this is it. This is our area detection area, and we can set that up over here. So this is it. I guess we are still getting that same error, and let me just fix this as well. So in our navigation agent, let's set so this is the, target desired distance. This is right now 1. So if our target position of enemy is player's position, so it will go up to this exact position, but it will have a distance of 1 meters. Okay, so I believe let's have this increased to say something like 2. That should, I believe, help us in fixing this error that we are getting. Okay, so yeah, and I think this is it. Let's run the game, and what is this? State is shadowing in already declared variable at line 18. So just to fix this warning, let's rename this to what should we say? Let's say enemy state. Let's have no warnings or errors. Okay, right. So now we are moving, and we can see that the enemy is in its look state, and if I proceed ahead into this area, now the enemy is heading towards me, and we are also not getting that error. We can even duplicate all these enemies and confirm that error is not going to be shown to us anymore, or maybe I should say we won't experience that because the main issue is fixed. And yeah, this is it. So let me just destroy delete all these enemies, all these extra enemies. And yeah, the logic for chase is the look and chase is done. Of course we need to do one thing in chase. So right now in our look state it's almost same as the idle state, and I'm keeping things very simple over here. Okay, in our chase state, so we need to have something now that transitions us to the attack state once the player once the enemy has reached the player. Okay, so let's do that. Here what we will do is let's add a comment state transition. Then we check if our let me just yeah, much better. So if our enemy's nav agent has reached its position, which is navigation finished, if the enemy has reached target destination, then we simply change enemy's state to the state of attack, and we return out of this function. And even though we don't have anything after this, so maybe this is not really required, but let's do this anyways in case we add something later on. But I don't think we will have anything, at least in this tutorial. So this part is done, and I will just do one more thing which I haven't done, and this is in the start method, which I believe I populated it for other scripts on other states, but I didn't do it in chase. So let's do that. But also, as I said before, I will be using the idle animation of this placeholder mesh for running to, and that's what I'm going to do over here. I'm going to increase the speed of this idle animation. So let's say 8, or maybe let's go with 4. 8 is, I guess, too much. So let's see. And okay, so yeah, we are already transitioned to attack, but since we don't have anything in attack, so the enemy is stuck over there. Let me just before that increase it to 8 only, so 8 works good. Yeah, this is so much better. And of course now we are in the attack state, so we have to start with the weapon animations. And for that we can go to enemy again and add reference to the weapon. I think maybe we can organize this better, but for now let's just do it this way only. So this is going to be enemy weapon, and then in our attack state we will first of all, I think, and while attacking, let's have the speed of this animation increased to 4. Now of course we will going to fix all these things. I mean, not exactly fix, but change these values when we add the final animation with real 3D models. But for now, for placeholder, let's just do all these ways through which we can simulate attack and all these different animations. Okay, so now let's finish up enemy attack script. So in start we will do one more thing, and that is we will play the weapon attack animation, which is simply calling the attack method. Now since we can make it looping, but just to make things consistent with player, where we were calling it in process or update, I will override the update method and call enemy weapon attack inside of it. So in doing so, I also need to make sure that I am calling state nodes update function, which I am not yet doing. So let's do that. And then it's going to be state node dot update and pass in the delta. So whatever is going to be the active state is its update function is going to be called. So with this done, now let me update the physics update method. So over here right now in attack state, we want to add a condition that if player is far away, or basically when player starts running away from enemy, we want enemy to transition back to the chase state. And that's because when enemy is going to be in attack state, its velocity is going to be 0, so it won't be moving, and we want it to move when player is running. So let's do that check right here. So similar to the chase state, I will store the player reference in a variable player just for ease, and let's define a variable out of range. So I'm going to be hard coding it, but yeah, for this particular case I think this is good to go, but if you want you can better refactor this part of the code. So what I'm going to do is I'm going to make use of enemy nav agent's target desired distance value, which is the distance before which it stops after it reaches the target destination, and on this I will just add some tiny value, let's say 1. So this 1 is the hard coded part. So with this done, I will check the distance of our enemy with the player, and if this distance is greater than out of range, in that case we change state of our enemy back to the chase state. Okay, so let's add a comment over here, state transition, and let me also set keep updating enemy's velocity. We can actually do this part in start itself, which is enemy's velocity is going to be basically 0, and only the y part is going to remain intact. So here we are, and finally we will do the rotation, and for rotation I'm just going to copy the code from the chase state. And just a thing I would like to point out, let me just first of all paste this code up here, and this is going to be our player's position, because we are going to be looking at player. So yeah, one thing I mistakenly did was that I have to set nav agent's velocity. Okay, so that is something just to have a note on. So yeah, this is it. Now whenever we switch to the chase state, we want to call end method of this class. End method is automatically going to be called when we change the state, and it's because of the logic implemented here. So I will basically override this end method, and what I will do is I will copy the following line, which is enemy weapon attack, and also the idle animation line. And so first of all I will switch back to the idle animation. Okay, so I believe we can make a function for this as well. So we can have something like switch to idle. Okay, and we can call it over here switch to idle, and for this we can just revert back to the default idle animation speed. Now of course when we switch on to state chase state, this will be this animation player will be again updated, but just as a safe practice I think it's okay to just call it in end. We can also do this thing in other places as well, but since I haven't done it, I think yeah, it really depends, but just to keep things simple I think I will just remove it. It's not required. Let's just go with this only. Okay, so this is our attack state done, and let's run the game and see how it works. And we get an error because we haven't set the reference. So let's do that, and let me just put the weapon above. It's right now very messy. Of course we can organize it much better, but for now I have done it all of these under references only. Okay, so we get another error, and it's regarding the attack origin. So yeah, I think I hadn't set that up yet. So okay, let me just do that. So the attack origin is going to be basically center of the enemy. So in the case of player we had the camera, and for enemy we didn't had anything like that. I mean we did had the eyes. Let me just see that. Yeah, I mean we can very much go and assign this, but I will use attack origin node only for now. So I will put it right up here and go to enemy weapon and assign attack origin. So our ray is now going to be started from over here. Okay, so now let's run the game, and yeah, this works good. I think in our attack animation speed we can reduce this a little. Maybe we can just have it as 2. I just see that I have when I'm sprinting the speed is just way too much. Okay, I think this is fine. I will be shortly adding arc the hit UI, so we can have much better player experience, as well as we will add player health shortly. But yeah, for now the enemy attacks are working, and so this part is done. Now what I will like to do next is, for now let's start with enemy health. Okay, I will like to destroy enemy when its health is depleted. So let's do that. So I will go back to the enemy script, and in stats I will define a health variable, and let's make it a float, and let's have the health as 50. And then at the very bottom I will define a function which is going to be take damage, and let's add an amount. It's going to be the amount of damage we take, but also we are going to have a hit pose, and this is going to tell us at what part of the enemy the hit was done. Okay, so this is just for subtracting health based on which part of the enemy's body the bullet is shot at. Okay, so first of all let's add logic for this damage, enemy damage. Okay, so I will go to the player weapon script, and we are over here. So we are showing the impact effect when our player's weapon raycast is hit with an object. So it's simply going to be I will add a generic statement over here, damage collided object. So if that collided object, which is going to be let me just confirm, collider. So if that result dot collider is enemy, okay, so if it's enemy, let me just save this value in enemy variable. In that case we will call enemies take damage function, and for now let me just have 0, and for hit position it's going to be the collide position which we had defined over here. Okay, and for the damage let's go with something like 10. So now back to enemies take damage function. I'm going to first of all have a check that if our health is already less than or equals to 0, we will just return out of this function. And then it's going to be another check, and that's that if our enemy hasn't detected us yet, that is our state is look, and if the enemy is shot, well in that case we want to change the state to chase. Okay, so now enemy is alerted. So there are two ways an enemy is alerted. The first is when a player enters a detection area, and the other is when a player shoots at enemy. Okay, and of course this check that I'm doing for look is because I just want to do this once only when we are at look. Alright, and then I will basically take damage. Basically the enemy is going to take damage based on hit position. So let's calculate that distance. Let me just make the screen full. So it's going to be our hit positions y component minus global position dot y, which is basically the bottom part of the enemy. Okay, and we want to have an absolute of it. So yes, this part is done. So if our distance is say less than 0.5, that means our distance to the hit. So let me just visually show you what I am really doing over here. So our enemy's position is going to be this at the very bottom. Okay, and that is the global position y, and then we have the hit position, and hit position can be anywhere where the bullet has been collided with the enemy. So if the bullet's collision is somewhere close to the ground, that is, the distance is going to be really less. In that case, we are going to give the least amount of damage. So this is going to be give least amount of damage. So it can be something like health minus equals to amount time divided by 2. Okay, and yeah, so basically we are giving half the damage of provided amount, because it's the shooting is near the foot. Okay, and now yes, I have used a hard coded value over here, and that's because I know the length, the height of the body, which is 2 meters, and yeah, this can be very much improved, but for now I'm just going to hard code it. I'll leave it up to you to refactor this part, but for now I'm just going to make it like this, and this is generally not a very good way of doing things, but to keep things simple for this tutorial series, I will be just hard coding it over here and not create another bunch of variables. I mean, what we can possibly do is get a percentage, something like maybe like 0.1 percentage of 2 meters, something like that, and yeah, that can be a pretty good way of finding the distance with whatever the height is. But for now I will just do this. Okay, so yeah, this is if the distance is less than 0.5, and if our distance is let's say less than 1.5, in that case we will basically give make let's call this keep damage as it is. Okay, I'm just doing it over here. I'm not really doing anything, but just mentioning this, writing this code just to point out this. Okay, this is very bad, I know, but this is very simple. Okay, and this part can definitely be refactored. Maybe I will refactor it in maybe in one of the further parts of the video, but for now let's do this only. And finally, if our distance is greater than or equals to 1.5, which is near the head, in that case we are basically going to give the maximum amount of damage, and this is basically a headshot. Okay, so yeah, this part is done. And yeah, one thing I just forgot to do, and that is I will have to subtract the amount over here. I just wrote keep damage as it is, but didn't do anything over here. And finally I will do the state check, and it's going to be if our health is less than or equals to 0, it's going to be our state changed from whatever the current state is to the enemy state dot death. So that's a very scary name. I see. Maybe I should have named it something like destroy, which I okay, anyways, so this is it. So with enemies health logic done, and when health is depleted, we go over to the death state. So let's write the logic for death state. So first of all, I will going to connect the enemies animation player's animation finished signal to on animation finished, and define the function. And if the animation name is death, in that case what we are going to do is simply queue out remove the enemy from the scene. Okay, free out, basically free out, that's the that's the right sentence. Anyways, um, yeah, this part is done. So as you can see in our death state, we are directly calling the death animation, and after that animation finishes, we simply remove enemy from the scene. As simple as that. And in the meantime, we also want to disable collision because we don't want any more hits to be registered. So for that, we will simply do enemy collision layer equals to 0, enemy dot collision mask equals to 0, and I think that is pretty much it. So let's run the game and see how it works. So I will first of all shoot at enemy's foot. Yeah, the enemy got destroyed, and now I will give a shot at doing a headshot. Okay, and let's see. Yeah, the enemy got badly injured and got defeated. So yeah, the logic for enemy health is done, and let's just for a simple check, let me just put in all these different enemies over here, and I think maybe it's going to be a good idea to let me just delete all of these, and just for the time being I'm going to set the top level to be true, so the detection area doesn't move. Okay, I believe it shouldn't move. Yeah, it's not moving. So let me just have these test enemy instances over here. Way too many, but let's see how it works. So now all of these are coming towards me and attacking me. Right now there is no logic for players health. I will just be implementing that, but for enemies health it's done. So I will now start shooting them and um, destroy all of these enemy, and yeah, this is it. So yeah, for this tutorial I think this is it. And for the part of adding enemy attack to player and player health as well as players health UI, I will be adding it in the next video because this video is way too long, and yeah, I mean it really takes a lot of time to so yeah, let's see. I will remove these extra enemies, and yeah, I will see you in the next video. Bye.